Okay, question number 38. Right, now let us start with this. Right. So in a photoelectric experiment, okay, I think I have not enabled my pen. Right. Okay. Beam of light is incident on a metallic surface W in a vacuum. Okay, there is one surface, light is incident onto it. The graph shows the current I varies with the PDV with three different beams X, Y and Z incident on the W. So what is happening? Photoelectric experiment is happening. A beam of light is incident on this, and then electrons are being emitted. It is being captured with the ammeter here, and there is a voltmeter connected over here. You can vary this voltage. You know, the more positive this becomes, what can happen? Electron flow is limited. The more negative this becomes, electrons are being accelerated. Okay. Now with this understanding, you look at this. There are three different beams being used, X, Y and Z. Okay. So for X and V the stopping potential differs, but for Y and Z the stopping potential remains the same. So this is what is being seen, and based on this we need to look for the patterns being observed. Okay, it has taken more than a minute. Let me close this. Right. To understand, sometimes I need to take a little bit more time. Okay, so now, so towards it, now how do we do with this? Now we know the photoelectric equation is given by EVS is equal to HF minus phi, where phi is the work function. The plate is not changed, so work function is not changing. Okay, now but your EVS is changing. Let me write this as Vy here, and this is Vx. Of course, Vy is equal to Vz here. Okay, so when you have something like this, now when phi is not changing and this is changing, then who is the culprit here? H should not change, F should change, right? Which means this Fx and Fy are different. Let us see, we have Fx and Xy, X1 and Y have the same frequency. No. So Fx is not equal to Fy, right? So therefore X and Y have the same frequency. Incorrect. Y and Z have the same frequency. Definitely it is correct, because you see Vy is equal to Vz, which means that phi is remaining the same. So this should also remain the same. So this is correct. Okay. Now we need to look at this one here. Y and Z have different intensities. Now you see, what is intensity? The number of electrons which are coming out per unit area, right? The energy per unit area is nothing but your energy per unit area per unit time is nothing but your intensity. Energy per unit area per unit time is intensity. So as you see here, the current here is larger, the current here is smaller. Why does this happen? The reason is because the energy of the photons that are incident onto the plate are varied, and as a result of it you get different currents over here. So thus you see Y and Z should definitely have different intensities. So this is also correct, and thus the correct options here are C, 2 and 3. Okay, let us move on to the next question, which is 39th